Hi and welcome to video 3 on this video series from Unit 4 Topic 2 Specialist Mathematics, and in this video we're going to be talking about differential equations of the form dy dx equals f of x. So let's have a look. When dy dx equals f of x, we get y equals the integral of f of x dx. These are the types of things you've seen, and that'll make this a fairly short video. One way to look at this that will be helpful for later on though is dy dx equals f of x. So let's multiply through by dx. And I've asked the question, is that allowed? It's a bit of a funny one, but let's do it anyway. We get dy equals f of x dx, and then let's integrate both sides. There's certainly nicer ways of doing this, but this is a really good initial way to understand what's happening. We get the integral of dy equals the integral of f of x dx. Now the integral of dy is kind of like saying the integral of 1 dy, and when you integrate 1 with respect to y, you get y, and then y is equal to the integral of f of x dx. And you knew this anyway. You knew that when you integrated dy dx, you got y, and you got whatever it's equal to on the other side. So let's have a look at example 3, and then we'll talk about what this kind of means in terms of differential equations. So in example 3, part A, a fairly simple one. If dy dx equals 2 cos x, then y is equal to the integral of 2 cos x dx, and that's equal to 2 sine x plus c. And then there's b, and b is this second derivative question, so we get d squared y dx squared, which means that dy dx is equal to the integral of e to the 2x plus x squared dx. So that's fun, and that is equal to a half e to the 2x, that's pretty easy to do, plus a third x cubed plus some constant. I'll call it constant 1, that's going to be important, and I'm going to give myself just a touch more space here, and then I integrate dy dx to solve and get my equation for y. So therefore y is equal to the integral of this again, a half e to the 2x plus a third x cubed plus c1 with respect to x, and that's equal to now a quarter e to the 2x plus 1/12 x to the power of 4, a third divided by 4 is a 12th, plus c1x plus some additional constant c2. And that's really the best I can do for this question without some known data points. But this is how you find a general solution to differential equations of the form dy dx equals f of x. Now, let's have a look at a family of solutions. For the differential equation dy dx equals 2x, we of course get y equals x squared plus c. That's just a simple integration. It's the plus c that causes a general solution here. Now obviously, if dy dx equals 2x, that implies a pattern within a gradient, but there are many functions that would have that same gradient pattern or gradient sequence. And so here's some examples of where c is equal to 0, 3, 4, and 9, and you can see I've color coordinated those, and they are just the parabolas being translated up and down. Now you've seen this is called a family of solutions. Because we don't know c, it's a general solution, there's a family of solutions. And the families of solutions are any situation where we translate the function up and down. That makes sense because we know that plus c is a vertical translation. And we just don't know the value of c. But if I knew that c went through here, this point which is 7, 13, well, I'd know it would be the parabola that sort of goes down here and is translated down to a negative value and back up. Okay, and I could work that out and get my c value from that coordinate, and hence I would know which parabola it is. So we have a family of solutions, which is every possible solution, which is basically a solution for every possible c value, and then we have particular solutions. So let's have a look at example 4. Find a particular solution to the differential equation dy dx equals 1 over the square root of x plus 3 at x equals 6, given that x equals 1 when y equals 10. So if we're doing it at x equals 6 and a particular solution, that actually means we're going to find the y value at that specific location. But if we know that dy dx equals that, then we know this. Remember, I can't deal with square roots, but I can deal with this. X plus 3 to the power of negative a half. And that gives us y is equal to the integral of that. It's plus 3 to the power of negative a half dx. And that's equal to x plus 3 to the power of a half over a half plus some constant, which I can write a little bit neater as 2 square root x plus 3 plus c. Now we know that at x equals 1, y equals 10, which leads us to 10 equals 2 square root 1 plus 3 plus c, which equals 4 plus c, and therefore c is equal to 6. And so we have y is equal to the square root, or 2 times the square root of x plus 3 plus c, and at x equals 6, y is equal to 2 times the square root of 9 plus c, so that should be a 6, and that's a 6. And the square root of 9 is 3, 2 times 3 is 6, so this is equal to 12. And so we get a solution of 12, a particular solution at that point of 12, or better yet, a particular solution, x equals 6, y equals 12, so 6, 12. All the best.